So one type of reaction that we haven't talked a lot about are displacement reactions. And in a displacement reaction, a solid metal can be dipped or placed within a solution of an ionic solution. It will then go into solution and a new metal will come out of solution. You will do this in lab. And so it turns out if you mix together manganese and lead nitrate, you can get lead out and the manganese can go into solution. So one of the hallmarks of a displacement reaction is that we have a solid plus a dissolved ion. And then the metal from one side goes into solution and the ion comes out of solution. Now, this may be familiar to some of you as parts of what's called reduction oxidation reactions. And in Gen Chem 2, you will learn more about that. So the activity series, kind of like the solubility table, is a method to predict how two elements or ions will interact. And so any metal on the list can be oxidized by the ions of elements below it. In a second, we're going to look at this list. And so it just tells you that the arrangement of these two metals on the activity series tell us whether or not they can function or what happens. So here's our activity series. And as a side note, do not memorize this. This is given. On an exam, or if it was on a quip, or anywhere else, you will get a copy that looks just like this. Okay, it will be in black and white because we're on a budget, but you will get a copy of this. And so what we know is that the relationship between these items is quite interesting. And so we can see that up here, we have strongly reducing. And so these, you can't quite see them. Down here, we know that if you were to buy expensive jewelry, it would likely be made of silver, platinum, and gold. So these are the noble metals. They do not react. Those are not letters. So gold will not necessarily, it is possible to go in solution, but it cannot interact with another metal on this table. So the other things that's interesting to interact with, so hydrogen here comes from acids and bases. And so when you interact with a metal, it's going to give off H2. So it's going to bubble. So in lab, you'll notice that in some cases, you'll drop a solid metal into the solution and a gas bubble will come off. That's the hydrogen gas. And so that is, in this case, a precipitate. So we've talked about how precipitates are solids. It turns out that precipitates that come off as a gas or a liquid can also be precipitates. They're just a little weird on the vocabulary word. So we know that the things at the bottom of the table do not interact, and the things at the top are quite vigorous when they react. So it's interesting to note that the further apart two metals are, the more vigorous or we could say dramatic the reaction is. So on this table, it can tell us what something happens. So solid lithium, when dropped in any of these metals, will react. But if you look at iron, there's a whole series of metals that will not interact with it here. So it's all about the relationship between these. So let's look at our examples. And so, this worked just perfectly. So when we think about an aqueous solution of iron 2 chloride, which is, let's not forget, FeCl2, oxidized magnesium metal. And so when we look at this, we can see that the Fe iron, which is noted, and the magnesium is up here above it. So we learned that metals will be oxidized by ions of metals below it. So our final answer here is yes, due to location. So in this case, for the next question, so we're going to clean off our hold on. Technical difficulties. Smallest eraser known to man. Feeling a little like an artist here. So in this case, what we have for our second one is which of these following metals will be oxidized by lead nitrate? So our first order of business is to locate the lead ions. So we see that here. And so we know that the metal of interest has to be above the other two. So I'm going to highlight in green. We'll start with our iron, which is up here. We also see zinc. And copper. So with the activity series, we know that metals will be oxidized by the ions of metals below them. So zinc and iron will interact. Copper will not. For the most part, when we consider the activity series, we'll ask questions. Will this interaction occur, yes or no? So if you were to drop copper into lead nitrate, nothing would happen. The lead nitrate would still be aqueous and the copper would still be solid. In that case, if you were asked, perhaps on a lab question, if you had Cu plus Pb, this is a solid, NO3 to aqueous, we're running out of space as usual, you would write down NR. This means no reaction. And so in that case, nothing happens. And so the activity series can tell you whether or not something will happen. The activity series is really important. So when we think about chemical potentials, so in Gen Chem 2 and in other science courses, we'll use this in a way to say, can we create energy or can we use this to create different things?